Welcome back, my dear friends. Так бы я сказал, если бы я вел конференцию на английском языке. И следующий доклад будет именно такой. Я хочу пригласить к нам сегодня сюда, на конференцию, нашего замечательного Дарко Месароша, который наш AWS Technical Evangelist. Дарко прошел огромный путь от Support Engineer, Solution архитектора, и сейчас он наш Technical Evangelist, который работает над многими вопросами, которые находятся в интересах комьюнити, а также всегда на каком-то на волне интереса в не только технической комьюнити, но и среди компаний, которые пытаются постоянно драйвать инновации, такие как Amazon Web Services. И сегодняшний доклад будет на тему Monitoring Operational Metrics with Amazon Timestream and Grafana. So, switching to English, and I want to welcome to the stage one and only Darko Mesarosh. Hey, Darko.
Hey,
welcome.
Hi. Thank you very much for having me here. It's been a pleasure. And you pronounce my last name okay. One of the few that does it okay, but it's Mesarosh. Thank you very much for the lovely intro. I could understand most of it. Oh, do I just go, or do we have to chat?
Come on, just go.
Let's go.
We'll
Thank
chat
you,
at the
Thank
end.
you. Okay. Let me kick it off. Well, welcome. First of all, thank you very much for your time, your patience, and your willingness to listen to English with me. My name is Darko, and today we will be talking about monitoring operational metrics with Amazon Timestream and Grafana. As Egor said, my name is Darko Mesarosh. I am a technical evangelist, a developer advocate, whatever you would like to call it. But at heart, I'm a builder. I'm a thing they used to call a system administrator. I used to automate a lot of things. I wanted to make sure I do it safely, but I also managed a lot of servers. And this is where we get to talk today about a lot of things and how can you actually deal with a lot of things, especially in operations. I'm based in Berlin, Germany, but I'm originally from Serbia. And actually right now I'm coming to you live from my mom's house. So yeah, this is my childhood room, so it's fun. Okay, let me click on the thing here and move on. Just quickly the agenda. I'm going to talk about you in the cloud. I'm going to talk about Amazon Timestream, and we're going to be looking at Grafana. If this is what you're here for, thank you, and please stay until the end. I'm very much happy to answer the questions you have. So, first of all, you, the developer, the builder, the engineer, the system administrator, the data analyst, the operations person, you in the cloud. It's a wonderful connection, right? You and the cloud get to do amazing things. However, the cloud is big. The cloud is really big, especially when we talk about AWS. First 5 years of AWS, we had 4 regions across the globe. Next 5 years, 7 regions. And just recently, 14 regions with 8 new regions coming soon. I don't like this map because not everything is in the place it should be for some reason. Sweden is in Finland, and yeah, don't look at the details of the map. But in essence, the cloud is big. And the things that happen in the cloud are also big. So if you come from a traditional system, you could count the number of servers on your hand, maybe, if you have big hands. But you usually knew which servers you had and where they're located. In the modern day, how many servers you have on the cloud tends to fluctuate. You tend to have a lot of those servers, a lot of EC2 instances, a lot of Lambda functions, a lot of IoT devices. You can have thousands and thousands of IoT devices, thousands and thousands of servers doing something. But how do you know what they're doing? How do you get this operational data, their CPU utilization, their memory usage, bandwidth, all of those things? How do you get all of that and still manage to, work it really good, especially in a huge system like this, right? What is it, 25 regions, 81 availability zones all across the world? You can use CloudWatch, absolutely. But there's better ways of doing it, especially if you want data that you need to react to fast and make some good decisions on it, right? Imagine you have 10,000, 20,000 servers out there serving your customer base across multiple different microservices and whatnot running on them. And you want to be able to get information from those servers, their operational metrics all the time. How do you do that? Well, this is where I'm going to talk about a couple of things and a couple of ways you can implement this into AWS, starting with Amazon Timestream. I'm not going to spend too much on the details here, but Amazon Timestream is a wonderful way to use a time series database. Why would you use a time series database? Maybe you have a lot of IoT devices. Maybe you want to analyze, and I hate this word, DevOps data. Putting DevOps in front of things is weird, but yes, operational metrics from your instances. Maybe you want analytics from your application and you need them to come in a specific time format, well, sequentially, so you know how to do and what to do with them. Building a time series database can be challenging, right? Doing it in a relational database is just inefficient, right? It's just rigid schemas, inefficiencies, limited integrations, all of these things are not fun. And building your own time series solution, well, you come with a lot of difficulties when it comes to scaling, decoupling real-time and historical data, etc., etc. That's why we have this wonderful thing, which a lot of people have been waiting for, me, myself included, is Amazon Timestream. It is, to use the marketing term, fast, scalable, and serverless time series database. Yes, it's a serverless database that's super easy to set up and use. One-click deploy. It gives you all of the performance you need at scale. It is specifically built for time series data, and like a lot of things we build, it is built from with security from the ground up. So that is really cool, and this is important because this thing kind of gives you the ability to focus on other things rather than building a time series database for yourself. Let's actually have a look at some time series databases. I'm going to actually go ahead and create a time series database here. So this should be large enough, I think. Yeah, good. So to create a database, click the big old yellow button, Create Database. I'm going to create an empty database here to just show you what does it look like, right? Create a database. I'm going to be using a standard database. I'm going to call it demo. There we go. You can specify what kind of encryption you want to use it. Do you want the managed keys, or you want to use something else? I'm just going to leave this as default and just basically make sure that it protects my data here. Also, you can do some tags, but I don't care for that right now. Create database. Boom, done. It has created a database for us. Now, okay, yes, it's a database, but database without data means nothing. So we need to have a table. So to create a table, we click the big old orange button that says Create Table. Give it a name. Let's call it My Demo Table. And we define data retention. This is very important because there are two ways of storing data on Timestream. You can store in memory, which is going to store the data within the memory, which means it's accessed really, really fast. And you store the data on magnetic storage. In essence, you would put something like you will store all of your data in memory for 1 day, and then store everything for, let's say, 5 days in magnetic storage if you need that. After this period, the data is gone. It's done for, right? Which is fair. Do you need all of your operational data or IoT sensor data for all time in this database? No. You would export it, you would do something with it, and, well, make some sense out of it. Create table, boom. That's it. The database has been created. Now, an empty database is no fun. It does have a table, but the table is empty. There's nothing here. Yeah. So let's actually do something else. Let's go ahead and I'm going to delete this. I don't need this table. I just showed you this for the sake of saying, hey, you can do that. I'm going to delete this table, and I'm going to actually go and delete this entire database. And I love the fact that it's so fast. I am actually going to switch into the command line, and I'm going to run a script that will create a table and add data to it. So I call it load? No, table load. No, time load. Yes, that's the thing. So this is a Python script, and I'm going to share the links later on. It's a Python script that will just create a bunch of sample DevOps data into this table. It's going to create a database called DevOps. It's going to create a table called host metrics, and it's going to fill it with information with fill it with information from a CSV file I have here. And all this is available to you. And this gives me a chance to talk about this a bit. Amazon Timestream gives you the ability to write to it using an API. So there's multiple different ways to write to it, but in essence, you can use your Bodo 3 SDK here to write into the database. And once those writes have happened, it just stands there, right? So you don't need to complicate things with agents or whatnot. You can directly write things into a database. That means anything that can run any piece of Amazon SDK can technically write into a time series database. Now, while this is happening, I want to talk about a couple of things. I have a couple of notes here because we're going to be looking at how you can actually use this data. What do I do here? It's in a database. So what? Amazon Timestream has SQL querying built in. It uses a SQL language-like thing, but with some additional special features. And I'm going to show you that as we go along. On top of this, it has a flexible schema. That means that you insert the data and the schema can be extended by newly inserted data. So for example, in this case, I'm inserting some CPU metrics for my imaginary DevOps scenario. But if I want to add some disk metrics, I can also do that by just extending the schema as I write new data to it, which is great. It's not rigid because sometimes you might have different types of data coming from different places. Now, I think it's going to end soon-ish. It takes a moment or so. I intentionally did this in real time because I don't want you to think I'm faking the data. Well, I'm faking the data because it's being created like this, but you can see we have a database called DevOps here, and that database has a table called host metrics. You will see that the database metrics are currently no data available because it is currently still loading, and it has finished loading. Perfect. So let's do some SQL queries because that's the fun thing. I'm going to close all this up like so. And I'm going to select a database called DevOps, and we're going to be using the host metrics table for here. We can see the current schema is this: host name, availability zone, region, measure name, timestamp, and a bunch of other things. You can actually preview the data by doing this and running the command, and you will see the preview data is, in essence, this: host name, availability zone, what region, and what kind of a measurement we're picking up, time, and the actual value of that measurement. So all of this is coming in a time stream, right? They're just constantly forcing the data into this table, and we can do something with it. So going back here, let's do something else. And I have a couple of sample queries here I want to run. Let's say, for example, let's run average CPU utilization for this database, for this table, for all EC2 hosts over the past 2 hours, while it is going to fill in missing values using linear interpolation. Have you ever used metric data from your instances and you're missing some data from sometimes because, hey, maybe an instance was overloaded and it didn't send data, and it kind of skews the data you look at? Well, this thing can use interpolation to kind of create a value based on based on the values it already has. So it can fill in the blanks. So if I run this, I think we're good. Last 2 hours. If I run this, let's have a look. It failed. Query syntax is invalid. What did I do? Host metrics. Let's see. DevOps host metrics. It looks good. Wow. 111. This looks perfectly fine. Once more, run. This is actually a sample query, which there we go. It works now. And you can see that it has returned 106 rows with the host name and its average CPU utilization, right? So this is the average CPU utilization of all our hosts here. And if we like just go down all the way, we will see that there's host 1, which is super low CPU utilization. And if we go all the way up, this is the host no HMK, which has the highest one. Now we can take it a step further. We can go here and actually look at the host itself. So let's do another query. I have another query saved here, which will look at a single host. So it will look into a single host, and this is the host, basically the same one we had before. It's going to look at the single host and find the average CPU utilization based been in the last at a 30-second interval for a specific EC2 host. Because this is time series, it's also going to be using spline cubic interpolation, where it's going to actually determine missing values, right? Potentially there may be a missing value. It's going to fill in the blanks for you as well. I'm not going to get into the math of spline cubic interpolation, but it's a way to kind of fill in the blanks for your spline. So yeah. So if I do run, hopefully it works. Excellent. So here it is. So this is basically for the last couple of times we see that it had spikes up to 80%. Well, see, you can see the other information like it was 26. You get all of this, these things for this entire host. Now, if you want to do more things like here, like I showed you here, you have sample queries. They're actually sample queries based on the DevOps data set, where you can have a look, like for example, find the average CPU utilization within the 30 seconds for a specific host, filling in the missing values using linear interpolation, right? And there's different ways of doing it, different ways of sample queries you can check out here, but it does support the SQL language with a bunch more additional things related to time series. So I'm not going to go through all of these things. You can check them out directly on the time series console. But this is fine, right? This is okay, I guess, right? This is something you can do when you get this data here, but that's not cool, right? You wouldn't keep this on a monitor in your office to check for CPU utilization and average memory usage and whatnot. You would not spit out this horrible list of information or God forbid, a CSV out there to do this for you. You would use something else. You would use something wonderful, something called Grafana, right? So let's talk about Grafana for a moment. What is Grafana? It's an wonderful open source tool that basically helps you visualize insights, visualize data from a whole slew of different sources, right? In this case, talking about time series, but basically it can visualize data from somewhere without actually having to move the data to Grafana. It will just take the data and work with it without having to actually relocate it somewhere else. It is super popular. It is, if you ever worked in operations, you may have seen Grafana. I use Grafana at home to monitor my temperatures and, I don't know, power usage in my power sockets and all those fun things. It's just a great way to do it. And I come from the world where the best dashboard back when I was a sysadmin was Nagios, and it was not the best thing in the world, at least back in 2009. So Grafana, it's great, it's open source, but actually when it comes to AWS, you can run Grafana in a fully managed way on AWS. We have this service called AMG, or Amazon Managed Grafana. It's a fully managed service. Basically, you don't have to worry about anything. It's a 4-click solution where you click a bunch of buttons and you have a managed Grafana. dashboard, not a dashboard, a workspace available for you to do all of the other things. It has native integration with database services such as Timestream and CloudWatch and a whole lot of things. It uses single sign-on, so there's no need to create separate Grafana user accounts or whatnot. It can use AWS single sign-on, which is just wonderful. And if you wish to use Amazon Grafana Enterprise, you can absolutely do that as well. Data sources, again, you can use managed service for Prometheus. You can use X-Ray, CloudWatch, Timestream, SNS, IoT Sitewise, Elasticsearch, MySQL, InfluxDB, Azure Monitor, Google Operations, PostgreSQL, and a whole lot of other things. All of these things come with the setup of Grafana. And if you need, you can actually switch to the enterprise version of Grafana, if you will. And I think it's all done through the AWS Marketplace. So a couple of clicks. Enough with the PowerPoints. Let's actually have a look at some things. Before we go, I'm going to use my command line again. This time, I'm actually going to go and I'm going to load some data into Grafana. Well, not into Grafana. I'm going to create an additional database on Amazon Timestream to add all of this information. So let's go back to Amazon Timestream and let's create a new database. So create database. I'm going to do standard database and I'm going to call it, I need a specific name to use. I'm going to call it Grafana DB. Good. It's case sensitive, so make sure you use the proper casing here. I'm going to leave everything as is, create database, go into create database, and I'm going to go and create a table. The table is going to be called Grafana table. Look at that. Data retention, again, I'm going to leave it for 1 day in memory, and I'm going to leave it for 5 days in the magnetic storage. All right, cool, boom. Okay, Timestream database is ready. Now let's load some sample data into this one. Again, I have a sample script here that will load some dummy DevOps data and continuously keep on loading this dummy DevOps data into Grafana. It's available on GitHub. It's a little application written in Python that does all of this for you, right? So I need to just do the following. Wait. I need to come back. I need to enter the bin, activate. Good. So I will be just loading some dummy data here, and I call it Grafana. Is it Grafana load? Yes, there we go. So if I run this, it's gonna load this database with it's gonna load this Timestream database with some dummy data. And it's gonna do it in multi-threaded mode. It's gonna create 30 Python threads. It's just gonna keep on hammering my Timestream database with a lot of information. Hopefully this doesn't destroy my network connectivity at home. I have not tried that. So while this is happening, let's go back to this. Let's go and create a Grafana workspace. So if you go to the Amazon Managed Grafana, click Create Workspace and give it a name. Let's call it Demo Grafana because we are creative. This Grafana will DevOps. Click Next. What authentication model you want to use? You can choose single sign-on or basically using SAML. I'm going to use single sign-on because it just works. So like that, it's enabled. Permission types. You can do service managed permission types or customer managed. Basically, customer managed permission types enable you to define your own IAM roles and policies to give access to certain things. Or if I do service managed, I just tell Grafana, hey, you have access to Timestream, and it will have access to Timestream. So I will use service managed in this case. And this is where I get to pick data sources. So when it comes to services, I'm going to just select Timestream in this case. So Grafana has access to Timestream if it needs. Okay. I don't want to use any notification channels, but I can also specify SNS. So it will use simple notification service to notify me through Grafana. Click Next. This all looks very nice. If I create workspace, boom, in a couple of seconds, it's gonna deploy myself a Grafana workspace. let's go back to this thing. As you can see here, this is just loading information into my Timestream database. It's going to keep on doing it. To have this thing stop, I need to Control C out of it, but I'm going to let it fill it with data. Okay, it's still creating. It has attached the managed policy for Amazon Timestream. So this is attached, basically an IAM policy that allows this Grafana workspace to access this, and notification channels. One thing when it comes to authentication is that I need to add a single sign-on user to Grafana so it can access it. Currently, it's in the creation process, and it actually just finished. But I need to add a user. I need to assign a new user to the Grafana workspace in order to use this. So assign a new user. I have a user myself here, and say assign users and groups. By default, the user is a viewer, right? Just a person who can view the Grafana dashboard, and that's it. But I'm going to make this user an admin. So once I do this, boom, I am an admin. And if I go back to demo Grafana and click on this URL, it should take me to Grafana. Sign in with SSO. I'm not sure if it's going to ask me for a username and password. It shouldn't because I'm already logged in. And boom, Grafana, right? Excellent. Now it's wonderful because it's all configured. It's, it has all the database data sources here, and all the things you need to do. But let's actually go and configure a data source. So I'm going to add a data source, and the data source in this case is going to be our Timestream database. So let's connect to the Amazon Timestream database. Select this one. It's going to be using the workspace IAM role, the permissions we gave it initially, and the region I'm going to choose EU West 1. Save and test. All right. Selecting the database. So we have the DevOps database, the one originally created, but we're going to use Grafana DB because this is the one we're filling with dummy data. I'm going to select the Grafana table, and I'm going to select the measure with the CPU system. All right, let's do that. Save and test. Boom, works. Excellent. We have connected the Amazon Timestream data source to Grafana. Now you can go ahead and build your dashboards with all of the elements from the time series database. But what this data source actually contains is a wonderful sample dashboard, the DevOps sample dashboard. So if I click import here, it's going to import this dashboard into Grafana. If I go to home, will that work? Or do I have to go to the dashboards? Dashboards, yes. There's the sample DevOps dashboard. And if I open this one, come on, reload, boom, boom, there you go. Oh, data, stuff is coming in. So this is the sample data that is being collected from Timestream. So, and it's gonna keep on being collected as this script keeps on doing it. So if I leave that open, it's just gonna constantly hammer my Timestream database with this data. And I can actually do something with this data. I can make this a dashboard and make it, make it actionable, make it so that we can use this in some scenario. Can I just zoom out a bit? And yeah, if you look at, for example, let's have a look at some of the things here. You will see that it is using this sort of SQL language you've seen before, and yeah, wonderful. Like, you can take these examples and modify them and use them at your own will, but like, these are quite complex things. But anything you throw into Timestreams, you can connect it directly with Grafana straight out of the box. You also may ask me, like, well, Darko, I have a Grafana running at my own on-premises, or I have a Grafana set up on EC2. You can absolutely use that as well. So it's connecting Timestream to Grafana is not only with the managed Grafana, you can do this also with your own configured Grafana. The only thing you need to do, you need to install the plugin. So you need to manually install the Timestream plugin. And you also need to make sure that your Grafana database, wherever it's running, has the appropriate permissions to access Timestream. And that's it. Everything else works just fine. And you can have all of these wonderful things set up and connected to your Grafana dashboard. and post them on your wall in an office, so you can start panicking when things go wrong. All right. Shall I leave this filling data? I can stop it. Yeah, I don't want to. Oh, there you go. Stop. Boom. All right. Back to PowerPoint and back to wrapping up stuff. So for wrap up, using Timestream gives you the ability to funnel a lot of the DevOps data, operational metrics, CPU utilization, network usage, disk I/O, all the things, all the operational data, your hardware devices, your EC2 instances, your Lambda functions, your IoT devices produce, and you can feed them into Timestream. And then you can use that data from Timestream to visualize it, to do something against it, and make a Grafana dashboard, right? So you should really be careful on finding the best way to ingest all that mass amounts of data and have a way to react to it fast. So combining something like Timestream and Grafana is really a really neat way to do it. You can get additional insights through all of the wonderful features of that SQL language, plus some special features coming in available in Timestream, plus the ability to do all of the lovely visualizations in Grafana and notify people. So if you want to check out the tools, the scripts, all the things I've showed today, it's all available on GitHub. So if you go to github.com/AWS Labs, there's a repository called Amazon-Timestream-Tools. There's examples. There's the code I've used for both the Timestream and also the Grafana part. There's examples, I think, in like Node.js, Java, Python, .NET. So if you want to see how different languages interact with Timestream, all of those things are there as well. So with that being said, thank you very much. Spasibo, дякую. My name is Darko, and yeah, I guess I get to talk to Ego again. So thank you.
Hey Darko, thank you so much. That was very, very good presentation, and I have here Igor joined me again because I believe that my knowledge and my power is not enough to ask you like really interesting and engaging questions. So I enforcing my team with Igor, so we can ask questions. But first, before we ask questions, I actually want to ask thank you and ask a question and see and read questions from the audience. So the first question is there a way to make common AWS services report their metrics to Amazon Timestream directly automatically?
So you don't do it directly from the service to Timestream. You can actually, because most services report their metrics to CloudWatch, you can actually connect those things from CloudWatch. Can you do that? Can you ship things from CloudWatch? I'm wondering now. To be honest, I don't know. Like you can get stuff from CloudWatch into Grafana, but I don't see a way of like getting directly operational metrics from CloudWatch to Timestream. So as I know, and I may be wrong, but there's no way to directly do it. They will be available on CloudWatch. You can take that information from CloudWatch and store them into Timestream in a roundabout way. But I am not yet aware of this thing. But I will make a note of this because I want to figure this one out. So please do follow me on the social medias. I will post my findings on this. So thank you. And sorry for the non-answer.
Yeah, and I believe this is a good challenge. This is actually where Darko usually take ideas for his hands-on workshops and videos. It's actually from you. So please, everybody, find this link for Slido and start adding your question. So in the meanwhile, asking the second question. Is it possible for Timestream to automatically interpolate data after some period of time and reduce amount and volume of the data it's stored? It's a very good question.
It's a very good question. So up to my knowledge, there is no way for Timestream to do anything against your data on its own. So you can run the queries in some sort of an automatic way, but it will not modify the data that comes in. It basically, think of this as a relatively short-term way of storing data, and then you do something with that data and store it somewhere else. So there is no way for it. Simple answer, no. But if you want to do something with the data, interpolate the data, modify it as it comes in, well, not as it comes in, once it comes in, you can do so and export the data to some other data source or data storage.
Got it. So I want to remind for everybody that the user who asked the best question gonna have a prize from our sponsor company NX, and Darko, for you as well. If you please try to memorize the best question from the audience, so you can name the winner at the end.
I'm writing them down, so yes.
Oh yeah, good. The next question is, so this is again interesting, very practical question. How do SQL queries against AWS Timestream perform compared to pushing custom metrics from the AWS CloudWatch to S3 and do similar queries with Asina?
So when it comes to performance, I wouldn't know the exact numbers to say here because I have not benchmarked them. But one of the things that Time Series has compared to just like traditional SQL is that it has this special features, right? I showed you a bunch of different ways you can do interpolation, like your spline cubic and linear interpolation. These are some of the features from Timestream that can help you modify that data in that sense. So when it comes to benchmarking, I wouldn't know. So, but the thing behind Timestream is that it is intended for data that is sensitive to be sequential, right? Data that you write with a specific timestamp and that data comes in sequentially. So the doing SQL queries against them, I'm not sure what when it comes to like the speed compared to doing it against S3 and Athena. I would assume that it's faster than doing Athena and S3 because the data here, especially the fresh data, is in memory. So it is much faster to access than something else. If you have like data that's older than a day, in my case, the access to that data will be slower because it's going to keep the data on magnetic disks. So the answer is, as always, it depends where your data is sitting and what kind of data you're working with.
Got it. Thank you.
Thank you, Darko. Another question actually inspired by our community is, how do we compare and match the Timestream with open source databases, for example, like InfluxDB, which is well known and widely used? So what's the difference, and when should we use what?
I will use the cop-out answer here. Compared to InfluxDB, Timestream is a fully managed, scalable solution that you don't have to worry about. Now, if you've been using InfluxDB and you have expertise in InfluxDB, and InfluxDB really does a good job for you, and it's a wonderful open source tool, I see no reason for you to switch unless you really want to hand off the operational aspect of managing InfluxDB. So comparing features of InfluxDB versus Timestream, I don't have enough information to see that. But if you don't have a Timestream database right now, and you need a Timestream database, I think time series database. I think Amazon Timestream is just a great way to do it because you've seen how fast it takes, how little effort it takes for you to create the database and the tables and all that stuff to start working with it. So I think this is where the answer lies in. It depends if you have experience or are using InfluxDB already, and is InfluxDB doing its job for you. And if InfluxDB does, if it's a solution that really works for you, stay with it. It's a wonderful tool. Again, I'm the master of non-answers. I'm sorry.
All right.
Yeah.
Do you know what kind of SLA do we have for the delivery of the metrics to Timestream? Is it like near real time, or it has some delays, maybe some predictable delays? How do we count on that?
Okay, so since I don't know the numbers, I know the only thing I know about Timestream is that the SLA is that the data will come in sequentially. That is the promise, right? The data will always come in sequentially. But what is the delay? I don't know, right? I would highly suggest to you to check out the documentation and see if there are SLAs defined. We do not have SLAs for all services, so I'm not really sure if there is an SLA for that for Timestream. But my answer to that would be, I don't know. I would check the documentation.
Right, and I think so. We have quite some questions. So I wonder, for how many time do we still have with you?
All day.
Right.
If you want. I'm happy.
So how do we provide metadata with the metrics? For example, in your examples, how does Grafana knows how to get where to get the descriptions and titles for all the graphs and stuff?
Well, so let's actually have a look, right? So if you look at like this thing here, so can you share my screen again, or should I be just like explaining what I see? I'm not sure how complex this is to the wonderful folks behind the production, but I'm gonna have a look at here, because what it does, it looks at all the data. It has a bunch of macros in there, right? So from the measurements, and it takes, like, if you look at the overrides, it gets all of that data from Timestream, right? It's the Grafana in itself does not have these things stored on itself. It pulls the data straight from Timestream. So with the data source plugin, it has all of these things. We're just running this raw query against it. So some specifics when it comes to metadata, to be honest, like, does it do anything more than this? I don't think so. Like, even looking at the overrides, you can do your traditional overrides by getting the data from this metric here. But as you can see here, it is all just your standard SQL query coming in from Timestream directly. Yeah.
I see. Got it. That's cool. That's cool. And one more question from the community is, what about API adapters? Is there some plans for supporting Prometheus format in Timestream in general about adapters?
You mean like getting data from Prometheus to Timestream? Is that the question? Okay, so I don't know. I cannot really comment on the roadmap of Timestream. Timestream. Currently, the way you can fill data into Timestream is by using the API, basically using the SDK, the Boda 3 SDK. But as far as I know, there is no way to funnel the data directly from Prometheus. So I would definitely keep an eye out on that one. But as of now, I have no information to share.
I see. Got it. Thanks so much. So while we're waiting for questions from the community, I was wondering to ask your question from myself. So maybe you can share some plans to if you're working on some content or you're working on some interesting blog posts or articles, because again, based on today's conference, I can name at least like few tools and few approaches how to like stream data, analyze data, query data. We have so many interesting approaches. They're all different. They are all suited for different use cases, and that's where you're actually blog posts helping a community to get this reference architecture, so get like specific cases covered. So like maybe you can share some of your plans to uncover some interesting use cases.
So I approach Timestream and Grafana as not a data analyst or a person who deals with that kind of data. I approach it as an operation person. I was the one who was maintaining servers and machines and clouds. So I approach this as, how can I use this data to best suit my needs as an operations person, system administrator, DevOps engineer is what you like to call them. So I'm currently working on something currently working on a blog post on observability. And one of the big parts of observability is getting the right data at the right time in the right format, and having a lot of data out there from all the different sources in a sort of a sequential manner, time series manner, is something great. So it's not yet published, but if you go to my blog at rup12, rup12.net, I have a bunch of blog posts there, but this one is coming up as well. So stay tuned for that. It's currently being written up. So observability is very important, absolutely, and I haven't talked about that today, but understanding the data. You don't know how your system works if you don't know what it does. So it is very important that you see things at the time you need to see the things, and without having to without having too much data that will confuse the living crap out of you. So yeah.
I see, got it.
Thank you, Darko.
I have one more question, actually. So, what was maybe you can share some interesting story for, like, for example, here during this year in 2020, what was your biggest aha moment when you were working or discovered some services or solutions, or you had something like preparing some interesting blog posts or materials?
So my biggest aha moment coming in from this year, well, actually, it was from the last 2 years. So I'm a big proponent of infrastructure as code, right? Infrastructure as code is the best thing that has happened. And again, coming from a very traditional background where I used to rack and stack servers, infrastructure as code saves a lot of my time. I've learned that infrastructure as code is not just about using the code and building things with the code. It's also using the code and building blocks from that code. We at Amazon like to say, we give you all the building blocks and you build things with it. Well, with tools such as CDK and Terraform, you can actually build these custom modules, custom constructs that are just custom pieces of code that can do specific things. For example, when I build a demo, I usually have a Bastion host somewhere. It's an EC2 instance that I use to access restricted parts of my network. I used to always create like an EC2 instance in CDK with a bunch of different settings and VPC configurations and whatnot. Then I figured out I could make a custom construct out of this one. Basically, call it the Darko Bastion that will create all the necessary things in 3 lines of code, and that's just wonderful. Since I started abstracting things from my day-to-day job into chunks of code, I found it more and more reusable. So that was a big thing for me. And if you have not tried those things out, if you have not tried building custom constructs in CDK called Development Kit, or building custom modules in Terraform, check it out. If you're an operations person, it's gonna save a lot of your time.
I see, got it. So, one of the questions actually was from today's session. I remember that was a rhetorical question about, serverless and, these low-code solutions. And what do you think in general about serverless and low-code solutions, whether they kind of like putting less pressure and priority on developers, and is the general question whether AI ever gonna write the code? It's answer definitely no. AI cannot write AI.
Yeah.
How do you know that?
Yeah, exactly. Are you an AI?
Oh my God. So, but the question about these serverless solutions, they rapidly come into life, and they're so convenient, managed, auto scale, failover, flexible. Like, what's your take on that?
Yeah. Okay. I am a server hugger. I love physical servers. I have a rack at home. I have a bunch of old computers and like Sun workstations at home. And I'm a fan of everything hardware. But I would never use that in a production environment. There's one thing having fun building things and this, experiencing and exploring and learning stuff. That's one thing. The other thing is your job. Having to maintain physical infrastructure now is just a fool's errand, right? So we switch to the cloud. When we take the next step, when we switch from server full to serverless and low code solutions, you're helping yourself not having to focus on the non-important things, right? You can integrate multiple different services together to do the same thing as when you had to spend a lot of time in just like producing glue code and just some boilerplate code that does things. So I think that the approach with serverless low code is just going to make every engineer's life so much better, right? Trust me, you're going to have a lot of things to work on. You're going to still be the big head, big brain here doing wonderful things. And I assume that's what you want to do, right? Nobody enjoys racking servers for a living, unless you do. But you enjoy building things, you enjoy learning things, you enjoy solving problems. And the no-code solution will not solve the big problems for you. It will solve the tedious, small problems that make your day bad, right? So I think that's a great direction we're heading to. But I wouldn't be concerned about you kind of losing your place in the world. If you're a true engineer, if you love to code like I do, you will find something to build. You will find something to kind of make a niche out of yourself. And no, AI will not replace us because AI cannot figure out regex. So I'm sure AI is not a potential danger to us.
Darko, before one last question from myself, I wonder, what is your favorite question that you heard today for our prizes and stuff?
I like the question about InfluxDB versus Timestream because I'm a big fan of open source. I think open source is wonderful. I talked about Grafana, and InfluxDB as an open source solution is something that helps a lot of people out there. And it's always important to find a balance between the two. I'm going to use open source InfluxDB and host it on myself, or I'm going to use Timestream on Amazon and do that. I think it's a great question, and you should always ask yourself that. Do not use a service just because it exists. If a thing does a job for you and it does it good, and you get benefit from it, use that one. So that would be my question, my favorite question today.
Okay, awesome. And maybe like last question from myself. So we have a lot of people who just join us and who start their first steps with AWS with joining the cloud community. They may have joined also the ramp up track, the other track. So if you would start learning cloud services, learning AWS today, what would you start with?
Okay. Where would I start with? I would start with serverless. Unless you have a really big need to write an application that is not serverless, start with serverless. But not like, oh, Lambda functions. Start with the entire serverless ecosystem. How does it work? Different connectivity issues, events, microservices, stateless systems. Do that. Check those things out. Change the way you approach when developing applications and workloads. Remove yourself from the traditional system of a thing running on a disk. Think about something that's serverless, stateless, event-driven. That would be my suggestion to you. And as a side suggestion, learn an infrastructure as code framework. That can be the serverless framework, that can be SAM, that can be CloudFormation, Terraform, Pulumi, CDK, whichever one you choose, learn one. It will make your life much, much easier.
I see, got it. Yeah, thank you for this point. And it was a question from Ilya Medvedsky, and please contact organizers, Ilya, to get your prize and prizes from our sponsor company NX. But Darko, thank you so much for your presentation, and maybe you have a message for community, or let please community know how to reach out to you and how to bring their questions and fuel kind of like your research and the work you're doing from the community.
If you want to contact me in any way, you can find me on Twitter, you can find me on LinkedIn, you can find me on Facebook, you can find me on MySpace. I don't know. Search for my name; it should be somewhere out there. Darko Mesarosh. You can spell it both Cyrillic and Latin. It doesn't really matter. I'm happy to answer questions. Do not be shy to message me. If I can help you answer a question or support you in some way with the AWS community or point you in the right direction, I would be happy to. So I always like to work with my Ukrainian AWS community. I've been in Kiev a couple of times, so thank you very much for this opportunity to kind of sync up with you. You can also find me on twitch.tv/AWS. I stream at least 2 or 3 times a week there, so make sure to find me there as well. I will always be wearing some ridiculous, ugly shirt. That's how you recognize this big bald head. Thank you all.
Thank you so much. Thank you so much, Darko.